Hello everyone, welcome to the world of data structures. But today's topic is rotations in AVL tree insertion, that are LR and RL rotations. Hi, this is your instructor Janice Shah. So let's begin with outlines. Students, first today we are going to learn about the RL rotation, okay, and then we'll talk about LR rotations. Okay, so let's start with RL rotation. First, that is RL rotation. Students, if you have seen in our previous lecture, rotations are very much necessary to make our tree balance. So whenever you perform an insertion operation in AVL tree, it is required to apply rotation if your tree is unbalanced. Okay. If your balancing factor is 0, +1 or -1, then your tree is balanced. If it is +2 or -2 or greater than +2 or less than -2, then it is known as unbalanced tree. Fine. So at that time we need to apply rotations over there. In previous session we have seen two different rotations. The first one is a left and second one is a right rotation. Okay. So now today is the RL rotation. RL rotation, which is also known as right rotation followed by left rotation. Again, please bring your notebooks and pen with you and note it down that RL rotation, students, it means that right rotation followed by left rotation. Now, the question coming in your mind, that's when we need to apply RL rotation. Okay, so students, when a node is inserted in left subtree of right subtree. Okay, so when the node is inserted in left subtree of right subtree, at that time you need to apply RL rotation. Okay, so which is the scenario for that? Let's check it out with the examples. So here we have the example, that is 66, 40, 80, 70 and 90 with us. Before performing any operation on tree, first you need to check out the balancing factor of each and every node. Okay, because after that we can say that whether my tree is balanced or unbalanced. So here we have three leaf nodes, students, that are 40, 70 and 90. So all three leaf node contains balancing factor 0. Now, if I talk about the node 80, then students, we can say easily that node 80, on the left side of the 80 we have one height, on the right side of the 80 we have one height. That's why the balancing factor on 80 is also 0. Now, for node 66, on the left side of the 66, students, we have one height, one level. Right side of the 66 we have two level, one for 80, second one for 70, 40. Okay, so 70, 90. Okay, so here the node 66 contains balancing factor 1 minus 2, that is -1. Okay, now let's do insertion operation over here. So here if we can see that I want to insert 68, so just do the same process as binary search tree. Okay, so first just check out with the root node. 68 is greater than root node, so it goes on the right side. Less than 80 goes on the left side. Then less than 70, so go again on the left side of 70. So 66 will be inserted on the left side of 70. Now what we need to do is, students, we need to check balancing factor again. After performing insertion operation and after applying a complete rotation, you need to check balancing factor again. So here this is my insertion operation. So after completing the insertion operation, students, I need to check balancing factor again. So all leaf node contains balancing factor 0. Okay, what about the 70? So 68 is on the left side of the 70, that's why 70 contains +1 balancing factor. Now for the node 80, on the left side of the 80 you can easily say that there are two height. Okay, so left subtree of 80 contains height 2, the right subtree of 80 contains height 1. So 2 minus 1 becomes plus 1. So again it's a plus 1. Now for the node 66, on the left side of the 66 we have only 1. Right side of the 66 we have 1, 2 and 3, so total 3. So 1 minus 3 becomes minus 2. Now tell me, here the tree is left heavy or right heavy? Students, check out the unbalanced node, or which node is violating our rule? That is node 66. Okay, so here the node 66 is violating our rule, but it is minus 2. That means tree is right heavy. Now you usually say that, sir, if tree is right heavy, then just apply left rotation. Tree is right heavy, then just apply left rotation. But wait for a minute. Here, just check out the right subtree or right child of node 66. Student, if my tree is fully right heavy, then 66 is my balancing factor of 66 is minus 2, and balancing factor of 18 may be minus 1, but it is not like that. Here the situation is minus 2 plus 1, minus 2 plus 1. Students, in such type of cases, you need to apply RL rotation. Okay, see how? Here the the node is inserted on left subtree. See, it's a left subtree of right subtree. If you can see, left subtree of right subtree. So we can say that the node 66 is violating just because of node 80 is left heavy. Node 80 is left heavy. So here you need to apply two rotations. First for the left heavy and then for the right heavy. So let's see. Here the next is 80, students. Here 80 is a left heavy. That's why we need to apply first right rotation on 80. We need to apply the right rotation on 80 and then left rotation on 66. First right rotation on 80 and then left rotation on 66. That's why it is known as RL rotation, where right rotation is followed by left. So first, see, here the tree is node is inserted on the left subtree of right subtree. See the arrows, left subtree of right subtree. That's why, students, you need to apply first. This is left heavy 80. See, check the part of 80. Okay, so for the node 80 it is left heavy. So to balance a left heavy node, we need to apply the right rotation. So just you need to apply right rotation over here on node 80, and then you need to apply left rotation on node 66. Okay, see, this is a whole RL rotation. Until and unless you complete your RL rotation, please do not try to write balancing factors. Okay, first complete R, then L, then get the answer, and then write balancing factor. So let's start with the first right rotation. Students, you always need to apply rotations over here, okay, on the below term. Okay, so that is, first we have 70. So to apply the right rotation, we can, so first is the right rotation on 80 node. So first, see how the things will change, how the figure will change. 70 will take the place of 80. Okay, so the 66 and 40 becomes as it is. 66 and 40 remains as it is. You just need to think about this 80 portion only, the right subtree only. Okay, so 70 will take the place of 80, then 80 will take the place of 90, and then 90 will go down of 80. Okay, now what about student 68? What about student 68? So 68 is just bring one level up, and on the left side of the 70 we take 68. So up to now you complete your first rotation, that is right rotation. Okay, what you do, you just apply right rotation node 80. So 70 will take the place of 80, 80 will take the place of 90, and 90 will go down. Okay, and 66 is just 68 is just bring a one step ahead on the left side of the 70. Okay, now apply left rotation. See, this is my last answer. This is my last answer. Answer means after applying the first rotation, this is our answer. So you need to apply the left rotation on this figure. Students, remember, you do not worry about the balancing factor because our R and L rotation is still not completed. This is a whole RL rotation. Okay. So what you need to do is you just need to apply the left rotation on node 66. You all know how to apply left rotation. How? First, bring 70 on the place of 66, 66 on the place of 40, and 40 will go down. So here it is, second left rotation. First, 70 will take the place of 66. So now students, 70 become our root node. Okay. Now the next 66 will become on the left side of the 70. So on the left side of the 70 we have 66, and on the left side of the 66 we must have 40. Okay. Now what about the remaining right side child of 70? So 80 and 90 will take uplift, and they placed on the right side of the 70. Okay. Now tell me what to do with node 68. We all have the data. We have completed our RL rotation, but still we remain node 68 students. So please wait. Do not apply balancing factors till now. Okay. So we have to set node 68. So just start with the comparison from the root node, where the root node students we have 70. Compare 68 with 70. Compare 68 with 70. 68 is less than 70. So move towards the left side. 68 is greater than 66. Move towards the right side. So students, 68 will set on the right side of 66. Fine. So this is our final answer after applying RL rotation. See, here you need to apply two different rotations. So in your notebook, you need to draw four different figures. First one is a question. Second figure after inserting 68. Third figure of the first rotation, and fourth figure of the last rotation, that is left rotation. Fine. So after applying the RL rotation, students, we have this final answer. Now just apply or to check balancing factors. So all three leaf nodes 40, 68 and 90 contains balancing factor, that is 0. Okay. For the node 66, left side it's 1, right side it's 1, 1 minus 1 becomes 0. So the balancing factor on the 66, it is 0. Now for the node 80, we have minus 1, and for node 70 we have 0. So here you can easily say that, students, that on the left side of the 70, right side of the 70 all have two heights. So 70 balancing factor is 0. Is there any node is violating any rule? Please do not check violation only on the root node. You have to check violation on each and every node. Okay. So is there any node that break the rule of AVL tree? No. Because all contains 0, plus 1 or minus 1. Okay. All contains balancing factor from 0, plus 1 or minus 1. That's why my tree is now balanced tree. Fine. So let's start with another rotation, that is LR rotation. Okay. So it is totally reverse of RL. You need to apply this rotation when the node is inserted on right subtree of left subtree. When you try to insert a node on right subtree of left subtree, again right subtree of left subtree, then you need to apply LR rotation. So let's see how it happens. So here we have our own tree, that is 66, then 40, then 30, then 50 and 70 with us. Okay. So first check the balancing factors. All leaf node contains 0, 40 is also 0, 66. Left side of 66 we have 2 height, right side of the 66 students we have 1 height. So it becomes 2 minus 1, that is plus 1. Now just need to apply the insertion operation. So if I want to insert node 60, just this is my tree, and that I need to apply or insertion operation on this tree. So first compare 60 with 66, it is less than, move towards the left side, 40. It is greater than. Then move towards the right side. It is 50. It's all again greater than. Move towards the right side. So now 60 is inserted on the right side of the node 50. Fine. So what you need to do is you just need to insert that 60 and then need to check about the balancing factor. So students, all if node contains balancing factor 0 and then it's a time for node 50. See, 50 on the left side of 50 we have nothing. Right side of the 50 we have one node. That's why 0 minus 1 becomes minus 1. So 50 balancing factor is minus 1 on the node 40. 40 contains 1 and 2. Left side of the 40 we have 1 height. Right side of the 40 we have 2 levels. That's why 1 minus 2 becomes minus 1. And then students, on the left side of the 66, we have height 1, 2 and 3. Height 1, 2 and 3. And on the right side of the 66 we have 1. Okay. So here 3 minus 1 becomes plus 2. Plus 2. Now see, the root node 66 is violating our AVL tree rules. Okay. So here our tree is this after inserting 60. So we can easily say that the 66 is violating our rule, but it is written over there that plus 2. Students, plus 2 means left heavy. Plus 2 means left heavy. Now check it out. On the left side of the 66 we have minus 1. That means it's a right heavy. It's a right heavy. So what is happening over here, that the right subtree of left subtree, where we are inserting our value. So the right subtree of left subtree is heavy. Right subtree of the left subtree is heavy. So when you found plus 2 minus 1 situation, you need to apply LR rotation. First, see, this is the right heavy portion. The node 40 is right heavy. Node 40 is right heavy. So you first need to apply left rotation on 40 and then right rotation on 66. So here it is. See, 66 is violating our rules just because of 40. Just because of 40, because 40 is right heavy. It's not left heavy. Okay. So what you need to do is you just need to apply first left rotation on 40 and then right rotation on 66. LR. Left rotation followed by right rotation. Again, LR stands for left rotation followed by right rotation, where you need to give first left rotation and then right rotation. Fine. So what you need to do is you just need to apply left rotation on nodes 40 and then right rotation on 66. So let's start with the first rotation, that is left rotation. So just apply left rotation on node 40, students. So 66 and 70 remains as it is. See, 66 and 70 remains as it is. Okay. Now start with the 40. So 40 and 50. So 50 will take the place of 40. 50 will take the place of 40. See. Then 40 will take place of 30 and 30 will go down. 30 will go down. Now what about the node 60? So 60 is connected with 50. So can directly connected on the right side of the 50. So here we have, that is 60. Okay. So now up to now you have just completed only first rotation. So do not try to write any balancing factor because this is LR rotation. It means you have to complete both rotations first. Okay. So now up on this figure I need to apply right rotation node 66. So on node 66, students, when we need to apply the right rotation, 50 will go on 66 and 66 will go on 70 and 70 will go down. So 50 becomes our root node. So here it is. On the right rotation, 50 becomes our root node. 66 will go on the right side of the 50. 70 will go on the right side of the 66. Okay. Now, what about the 40? 40 will go set on the left side of the 50. Okay. And 30 is on the left side of the 40. Fine. So now it's turn about node 60 because we have to set toward 60. It is still remaining in our figure. So now start comparing from the root node 50. So 60 is greater than 50. Move towards the right side. 60 is less than 66. Move towards the left side. So now 60 is inserted on left side of the 66. This is the completion of LR rotation. Okay. Now wait. After completing or after getting the answer, we need to check the balancing factor again. So all if node contains 0, 40 has +1, 66 has 0 and 50 has 0. So now my tree is balanced tree. My tree is balanced tree. Okay. So students, these are the 4 rotations we have seen. First one is a left rotation. Okay. So students, when your tree becomes right heavy, you need to give left rotation. When your tree becomes left heavy, you need to give right rotation. There are 2 rotations. Then we have RL and LR. So in which situation we need to give such rotations? So when your left subtree of right subtree, see, when your left subtree of right subtree is heavy, then here you need to apply right and left, that is RL. When your right subtree of left subtree is heavy, then you need to give LR rotation. So how to remember in exam? That's why I bring you the conclusion of the AVL tree insertion here. See, just focus very carefully. There are situations given over here, and according to situation you need to apply the rotations on that nodes. Okay, so first we have such type of situation. See, node over there on the left. So here it is. This is +2 +1. See, focus on the node, violating node. Focus on the violating node. +2 +1. See, +2. Another left side of it is +1. That means this tree is known as left heavy. That's why on the left heavy we need to apply right rotation. So here it is, right rotation. Now next we have such type of situation, number 2, where violating node has -2 -1, -2 -1. Now again focus on the violating node. It contains -2, that means it's a right heavy, and the right child is also contains -1, that means it's also right heavy. So right heavy type of the tree is right heavy, and we need to give left rotation. Also remember that you have to give the rotations on the violating node only. Okay, so this is a right rotation. Now this is situation number 3, where situation goes like this: +2 and -1, +2 and -1. If you can see the the violated node contains +2. On the left side of the +2 we have -1. So such type of situation is known as right subtree is heavy of left subtree. Okay, so here due to -1 you need to apply first left rotation, and then right rotation over there. So it is LR, it is LR. Okay, so now this is the figure number 4. In such situations when you have -2 +1, that means according to -2 we can easily say that it must be right heavy. But wait, it is right heavy, but its left child is heavy also. So for left child we need to apply right rotation. Okay, and then over here we need to apply left rotation. So this is R rotation followed by left. So right rotation followed by left, which is known as RL rotation. Okay, so in next lecture students we talk about the examples of AVL tree, but before that you have to remember this conclusion, that you need to apply which rotation at which time. Okay, so that's it for today's lecture. Thank you so much students.